Here's another example on the probability of the complement of A. The drama, mathematics, and jazz clubs have 32 members, 33 members, and 39 members respectively. Find the probability that a randomly selected club member belongs to at least 2 clubs. Okay, so we're looking for the probability that the person we select belongs to at least 2 clubs. Now, let's study our diagram here. Notice I have a drama club, a mathematics club, and a jazz club. And notice how some members that are in jazz are also in drama, or maybe they're in jazz and also in math, and maybe they're in all 3. Okay, so again, we have 2 approaches to this problem. I can just find the probability of at least 2. At least 2 means the probability that they belong to 2 clubs or 3 clubs, right? And you know how to do this probability. This would be the probability of being in 2 clubs plus the probability of being in 3 clubs. So we can do this, and then I'll show you the second approach, which is with the complement, which is much easier. Okay, but I like to do this one just so that you can appreciate that the complement is a better way to approach this. Okay, so before we start looking for the probability of a person belonging in 2 or 3 clubs, let's see how many students we have in total. Okay, so let's count. I have 10, here's 10, and 10, 20, and 11 makes 31, and 8 makes 39, and 39 plus 8 makes 47, and 47 plus 7 makes 54, and 54 plus 6 makes 60 students. So let's just make a note of that here. I have 60 students. Now be careful. When we add 32 members and 33 members and 39 members, I don't get 60 students, but that's because out of these 32 members, I will have some of these members in this club also, okay? They are repeated members. That's why this number will always be greater than the number of total students that I have, okay? So now that I know the total amount of students, I can try and find the probability of students belonging in 2 clubs. So out of 60, how many students belong to 2 clubs? Well, notice here that these 11 students here belong to both jazz and drama. These 10 students belong to both jazz and math, right? And these 7 students here belong to both drama and math. So I will have a total of 28 students that belong to 2 clubs. Plus, how many students out of 60 belong to 3 clubs? Well, the only amount is right here in this intersection. This piece here shows you the amount of students that belong to all 3 clubs. 8 students belong to all 3 clubs. And that will give you a total of 36 out of 60 students. Now, this is not easy to visualize which students are in 2 clubs or in 3 clubs. It's difficult sometimes for some students. Let's do the second approach. The second approach is finding the complement of event A. And what is event A? This is event A, that I have a student that belongs to at least 2 clubs. So the complement of having a student that belongs to at least 2 clubs is the probability of a student that belongs to just 1 club. That would be the complement, right? If there are 3 clubs, then the complement, or the rest of the students that are not in this event, would be the students that belong to just 1 club. Okay? And these you can easily see. There are 6 students that belong just to the drama club, 8 students that belong just to the math club, and 10 students that belong to just the jazz club. So the probability that they belong to just 1 club out of 60 students would be 10 plus 6, which is 16, plus 8, which is 24 students out of 60. Now remember, when I work with complements, it's just a tool that facilitates me finding the probability that they asked for originally. So originally, I wanted to know the probability of selecting a student that belonged to at least 2 clubs. That equals 1 minus the probability of the complement of A, which is 1 minus the probability of belonging to just 1 club, which is 1 minus 24 out of 60, which is 60 over 60 minus 24 out of 60, which gives you 36 out of 60. And that's exactly the same answer I got with the first approach. So you see, you have 2 possibilities of attacking this problem. You could do it the old-fashioned way, where we learned how to do the probability of A or B, or you could use the complement. In this case, I think it's much easier to work with the complement. I hope this problem and this example helps. I think I'll do one more video. I'm not sure, but if I do, I'll see you in the next video.